It's filtration. I can actually take liquids with bacteria, pass them through a filter, and if the pores are small enough, the bacteria can't go through. So this is really good for different drugs, different solutions, vaccines that you can't use other types of physical methods to control microbial growth and you don't want to add chemicals. You can pass it through a filter. The smaller the pore size, the more you get rid of. You can get pores that will get rid of bacteria. You can get pores that are small enough that you can get rid of viruses, but they're more expensive from that. I actually have an example of that one too. Again, thanks to my husband and all his prepping and backpacking adventures. This is a product called the Life Straw, and it is a filtration method of getting clean drinking water. And so presumably it's got the filter in here, and you can actually just put it in the pond and take here and just drink the water straight out of that. And because of this filter, it will remove any protozoan cysts, any bacteria. Now this one won't get rid of a lot of viruses, but in North America, ponds and drinking water, viruses aren't an issue. Well, that's not true. Not as big of an issue. Now different other countries have more problem with viruses in the water, but our country's not quite as bad. But either way, I can boil it to get rid of the viruses, and then I can use this and get rid of protozoan cysts. I can use both of those methods to make it very safe. But this actually works pretty well as well. So you can check out this company and see how that works. So filtration. How do we use filtration? They use it in treating drinking water in water treatment plants, sewage to contaminate from that. And again, we already said smaller ones to do drugs and other types of things. Okay, so another physical way we can control microbial growth. If I add enough salt and enough sugar to the outside of a cell, then I'm going to alter the water, and that will control microbial growth. This is using osmotic pressure to inhibit microbial growth. So I am a sailor, and I caught some fish, and now I'm going to just cover it in salt. And this, you need to go back to what you remember from hypotonic and hypertonic. Back to my little whiteboard here. And so if I've got a cell, here is a cell. So I've got a fish. That's my fish. And this is my bacteria on my fish. This is not drawn to scale, but I got bacteria. We'll draw a little bit better. I got bacteria living on my fish. My fish is now dead, so I'm going to get more and more bacteria living on my fish. What I can do is I can add a solute to the environment. I can cover this bacteria, the fish, and any bacteria that is growing on it with salt. Now, when I talk about that, what's going to happen to the water? Going back to hypertonic, hypotonic. Hypertonic, if I have more solutes outside my bacteria cell, my water is going to leave my bacteria cell and go outside my cell. We know microorganisms need water. All the water is leaving that bacteria because there's salt all around it. This is a way we can physically alter the environment to control microbial growth. This is how fishermen would catch fish and then be able to survive off that for a long period of time and preserve that on the boats. Jams and jellies work the same way. They just use sugar as the solutes for that. Now, with our jams and jellies, and you know this, your jams and jellies will last a very, very long time in your refrigerator. Molds will still grow. They are less susceptible to this method of controlling microbial growth. So watch out for the moldy jams and jellies. All right, that's using osmotic pressure to physically alter the environment and control microbial growth. All right, radiation. I can alter my environment by increasing the radiation in my environment. There's ionizing radiation and non-ionizing radiation. Let me talk about the ionizing radiation first. This is an effective way to control microbial growth. Let's talk about gamma rays, which is a type of ionizing radiation, and our strawberries. Now, I don't know about you, but I go to the grocery store and I buy strawberries like this, and after one day, I swear, they look like this. Maybe 2 days max. They look like this. So what is a way, and why do they do this? Well, that's bacteria. There's bacteria on here. There's fungus on here. That is the microorganisms are growing. They're using the strawberries as a food source, and my strawberries are rotting. This is a problem. So I like my strawberries, but I don't want all the microorganisms that come with them. If I treat my strawberries, or if the companies treat the strawberries with these gamma rays, which are approved by a lot of these organizations, Food and Drug Administration, U.S. Department of Agriculture, Environmental Protection Agency, the World Health Organization, all of these have approved gamma rays to use to control microbial growth for meats, fruits, vegetables, spices. We can do this. We pass these gamma rays through the fruit. The radiation in this type of thing does not build up in the fruit. So it's passed through the fruit. Any microorganisms have lost their reproductive ability. They will not grow. Now, any seeds in the strawberry have also lost reproductive ability, but I'm not interested in planting the seeds. I'm interested in eating the strawberries. So passing the microorganisms, passing the gamma rays through these microorganisms, will get rid of anything growing on there. If it's not growing on there, then it's not going to desiccate. And my strawberries aren't going to look like mush. Now again, got it out in the environment. Can't keep it forever. It'll pick up more microorganisms, but I can keep my strawberries for much longer than the few days that it seems to work. So gamma rays is an effective means of controlling microbial growth, and it's proven safe. We've been using this for decades. We've got lots of different studies on this, following long-term studies with growth. It doesn't, unlike other forms of radiation, it doesn't stay in the strawberries. Strawberries, it gets passed through, and then there's no residual radiation. So you consuming the strawberries is perfectly healthy. Okay, you've probably not heard of this. If a fruit or vegetable or a meat has used this method of microbial growth, it does have to have this label on this. You've probably not seen that, and it's because in this country, we're not big on this. We do have to label it. It says that it's been radiated. In public perception, if I told you were eating radiated strawberries, your first gut reaction is usually negative. So in this country, we're not big on this. We're very cautious about the use of radiation. We're very fearful of it, and we're worried about it. So whenever this label goes on, things don't sell as well. So if this label goes on, it doesn't sell as well, then people aren't going to use it. So we don't use this a lot in this country. You probably have already eaten something that's been irradiated, because our spices, if we get this from other countries, we don't have to put the label on it if it's a certain percentage. So a lot of your mixed spices, they'll use this in other countries and then they get shipped to here. So you're probably eating irradiated food, you just don't know it. But here we don't use this as much. So it will kill anything, kills microorganisms, their larvae, their eggs, and therefore lengthens the shelf life. We do use radiation to sterilize dental and medical supplies, so it is an effective physical way we can control microbial growth. Now that is ionizing radiation. We can also use non-ionizing radiation, and you've heard some things about that even with this COVID-19. They're like, put it outside, let the sunlight get on this UV light. If you leave it enough time, UV light can control microbial growth. So that is good. What it does is it damages DNA. These thymines, instead of binding to the other strand like they're supposed to, they bind to each other. So it creates these thymine dimers. But this is also a way that works to control microbial growth. Now, what you need to know, just like when you're going outside for your suntan, UV light doesn't penetrate very well. So clothing, hats, umbrellas, shade, we use that to protect ourselves from UV light. Same thing. If I'm trying to use UV light to disinfect drinking water, and they do use this in water treatment plants, then it's got to be able to penetrate. So it's good for disinfecting water. It's good for disinfecting air. They actually use this in hospitals. There's a machine that they can roll into a patient's room and use UV light to get rid of everything there, and that works well for surfaces that the UV light can contact. Anything below the surface is not going to come in contact. It doesn't penetrate through surfaces. So it's great for air, it's great for water from that. We get a lot of things. Oh, my husband wants to buy one of these so bad. The little things that you can put your phone in and get UV light to do that. Those are hot right now, especially with this COVID thing. I think they sold out like completely. Are they a good idea? Are they a bad idea? They'll work, but so will a little alcohol wipe. And then remember, it will not penetrate. So if you have, here's your phone, and you've got organic matter, dirts, oils, anything from your hands on your phone, you stick it in that UV light, it may not penetrate. You may not be doing what you think you're doing. So yes, it's a good method. Just know the pros and cons from that. All right, so UV light is a way to physically alter your environment to control microbial growth. Okay, so we made it through all the physical methods. This table is in your book. This is a good table that's got all the methods in there. It's got your conditions. Don't need to memorize this table, but a couple of them I highlighted. I think you should know how long you should boil water for it to be as safe as possible. So don't memorize this, but it is a good method to compare these. And this column, how do we use it? Because on your exams, I'm not going to be interested in you parroting back information. I'm going to give you a scenario, and I want you to be able to pick the best disinfection method. Know the pros and cons, know when this is good and when it's not good. So that's what's going to do for that.